Hey team, we're going to go ahead and write some examples of rational functions with certain attributes while highlighting some of the content from this unit. Let's take a closer look. So we need a vertical asymptote at x equals 3. So essentially what we want is we want a rational function where it creates a asymptote at x equals 3. Okay, so now understanding that means that the denominator cannot be 3. So essentially what that means, the denominator cannot be x minus 3. The reason being is x minus 3, when I substitute 3 in, it gives me 0. I can put a 1 on the top. I could transform it, put a 2. I could put a 3, so on and so forth. And I have, as long as that denominator is x minus 3, I am good to go. Next up, we're going to turn it up a notch. It says a vertical asymptote at x equals 0. So that means at x equals 0, it's going to mirror the y-axis. And what number in the denominator makes it so that x is going to be 0? Oh, well, x. Now this next part is a removable discontinuity at x equals 2. Basically, at 2, there is an asymptote, and essentially it's removable, aka it cancels. So x minus 2 creates that asymptote, and in order for it to be removable, it needs to be in the numerator as well. It's removable because they cancel. However, let's go ahead and write it in just base form, and it's going to be x minus 2 all over x times x minus 2. If you want to, you could even be special and distribute the x to be x squared minus 2x. They are equivalent expressions. All right, let's turn up the volume. So I have a vertical asymptote at x equals 3, x equals negative 2, meaning x minus 3, and x plus 2, because these situations create a 0, and a removable discontinuity at x equals negative 5. So that means in the numerator and the denominator, there's a x minus 5. Voila! Finally, the last one, there is no vertical asymptote and a removable discontinuity at x equals negative 3. That means x plus 3 is in the numerator and the denominator. No vertical asymptote. Notice how there's no other factors, and we are good to go. That's it for now. It's been fun.